Bernoulli trials, in n Bernoulli trials. So here I shall derive that PMF. I shall derive the PMF of a variate that represents the probability of X failures in n Bernoulli trials. Now, how to derive this? Suppose that, now you see, we have n trials. You can take the example of the tosses, 10 tosses of a coin. And suppose I need to find the probability of, say, 6 heads in 10 tosses. You can take that way also. Fine. Now here you see, suppose we assume that the first X trials giving me success and remaining n minus X trials giving me failures. So that means this is the sequence. First X trials giving me success and remaining n minus X trials giving me failures. That means in this way I can get X successes in n trials. But remember one thing, this is one of the possible ways. This is one of the possible ways. So plenty of other possibilities are there in which I can get X successes in n trials. It's possible that the first trial giving me success, then failure, again success, again failure. In this way I get success X times, and remaining the trials, all the trials giving me failures. Fine. So suppose we just assume that this is the possibility, the sequence of success and failures. Now what's the probability of this sequence? That means probability of X successes in n trials. So just I take the probability of these sequences, and as the trials are independent, so the probability of success in first trial is independent of the probability of success in the second trial. So all these events are independent. So applying the multiplication theorem of probability, I just write this here. We know that PA intersection B intersection C equals to PA into PB into PC if the events are independent. So here S means S intersection S intersection S intersection. This intersection is not represented here. Anyway, so as the trials are independent, so these events are also independent, and I can write this way, PS into PS into PS in this way. How many probabilities are there? Probability of success X times. How many probability of failures? N minus X times. That means PS, as I assume that probability of success is P, just our assumption, and probability of failure Q. So I just write P into P into P, then Q into Q into Q. Now how many P's are there? Actually X P's are there, so P to the power X, and here N minus X Q's are there, so I write Q to the power N minus X. Now see, I already said this is one of the possibilities. This is one of the possibilities of getting X successes in n trials. Now plenty of other possibilities are there. Now my question is that how many possibilities are there to get X successes in n trials? How many possibilities are there? Actually, if we apply the concept of combination, there are NCX possibilities are there. That means there are NCX possible sequences are there where we get X successes and n minus X failures. Now to find out the probability of X successes and n minus X failures, we need to consider the other possibilities also. Now here it is said, out of n trials, x successes may occur in NCX mutually exclusive ways. You see, NCX mutually exclusive ways. Now you take the example of 6 heads in 10 tosses of a coin. It's possible that first 6 tosses giving you the head and remaining 4 tosses giving you the tail. It is possible that first one is giving you head, then tail, then again head, then tail. So in this way 10C6 possibilities are there. So to find out the required probability, we need to take the union of all possibilities. For example, PA union, B union, C union, D union, in this way. Fine. So all these possibilities are not written here. You just try to understand there are NCX mutually exclusive possibilities. That means probability of this type of one possibility, union, another type of possibility, union, another type of possibility, dot 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 dot, union, the last type of possibility. In this way, how many possibilities are there? NCX possibilities are there, and NCX mutually exclusive possibilities are there. Now to find out the required probability, we just sum up all these possibilities. That means PA union, B union, C union in this way equals to PA plus PB plus PC in this way. Now when we sum up all this, actually we shall get PX. Here it's written PX, just make it correct. Px equals to NCX q to the power x q to the power n minus x. And here the possible values of x written 0, 1, 2 up to n. I already explained. Mean and variance of binomial distribution. Expectation of x. How we write? Summation x into probability. You write that way. P x capital X equals to small x, as you write. Now what is Px? Px is nothing but NCX p to the power x q to the power n minus x. And we write NCX this way, q to the power n minus x, p to the power n minus x. And n factorial I can write this way, x factorial I can write this way, and n minus x factorial I write this way. You will understand just after a few minutes why I write this way. And here one p is there, that's a printing mistake, that's why I have cut this. Q to the power n minus x and p into p to the power x minus 1. I have written p to the power x this way. My motive is to get the term np outside summation. So I have taken out n and p outside summation. So what remains? You can add one more line. If you are not comfortable with this, you can write one more line as n minus 1 factorial divided by x minus 1 factorial into n minus 1 minus x minus 1 factorial. Fine? And q to the power n minus x, p to the power x minus 1. Now what is this? You see, n minus 1 factorial divided by x minus 1 factorial into n minus 1 minus x minus 1 factorial. What is this? You see one thing, this x gets cancelled with this x. So what is this? This is nothing but n minus 1c x minus 1. And these two terms as it is. Now if I expand this, first of all, I put, you see one thing, you see the range. Here x equals to 0 to n, and here we are writing x equals to 1 to n. You can write this x equals to 1 to n, in fact from here. Why? Because if I expand this, the first term I put x equals to 0. Now as I put x equals to 0, the entire terms becomes x equals to 0. Everything becomes 0. So the next I put x equals to 1. So I can write x goes from 1 to n right from here also. And another logic you can find here. You see, if I put x equals to 0, then 0 minus 1 factorial, that means minus 1 factorial. That's a meaningless. So that's why I put x goes from 1 to n. I write x goes from 1 to n. So now if I expand this term, first I put x equals to 1, that means n minus 1 c 0. Anything c 0 means 1. Q to the power n minus 1, this one, and p to the power 1 minus 1, that means 0. So what I get? Q to the power n minus 1. Then I put x equals to 2, n minus 1 c 2 minus 1. 2 minus 1 means 1, so I write n minus 1 c 1, q to the power n minus 2 into p to the power 2 minus 1, that means p. In this way, the last term we get p to the power n minus 1. Now this is nothing but the expansion of q plus p raised to the power n minus 1. And as we know, q plus p equals to 1, because we know q is nothing but p minus 1, or q plus p equals to 1, so I get np. So for a binomial distribution with parameters n and p, the mean or the expectation is np. You are to remember this term. Variance, expectation x square minus expectation of x whole thing square. Now expectation of x, already we have got this value np earlier, so np whole thing square. Now here actually I have written x square in this way, x into x minus 1 plus x. You see, we get x square. Why? For our own comfort. Now expectation of sum is equal to the sum of the expectation, so I can write expectation of this plus expectation of x, and this as it is np square. So I get this one, expectation x into x minus 1 plus np minus n square p square. Now I find out this one. This is a function of the variable, it's a phi x. So I write this way, x goes from 0 to 1, x into x minus 1, px. It's written bx, make it px. Here also you can write x goes from 2 to n. Why? Because if we put x equals to 0, then the term becomes 0. If I put x equals to 1, here 1 minus 1, 0. So I can write here also x goes from 2 to n. If you wish, no problem. So x into x minus 1, and I just write the formula. And here my motive is to get the term n into n minus 1 p square outside the summation. So that's why I have written n factorial. That's why I have written n factorial this way. N into n minus 1 into n minus 2 factorial. And x factorial I have written x into x minus 1 into x minus 2 factorial. You see, this x into x minus 1 gets cancelled with this one, x into x minus 1. And this one, willingly I can write n minus 2 minus x minus 2 factorial. And this way, very simple. So I have taken the term n into n minus 1 p square outside, and what remains? You see, n minus 2 factorial divided by x minus 2 factorial into n minus 2 minus x minus 2 factorial. What is this? This is nothing but n minus 2 c x minus 2. Q to the power n minus x, p to the power x minus 2. So first term, if I put x equals to 2, n minus 2 c 0, anything c 0 means 1, q to the power n minus 2, this is q to the power n minus 2, p to the power 2 minus 2, that means p to the power 0. So 1, so first term remains q to the power n minus 2. In this here the last one is this, and this is nothing but the expansion of q plus p raised to the power n minus 2, and q plus p is 1. So we get expectation x into x minus 1 as n into n minus 1 p square. So variance of x, I evaluate this way, the result comes out npq. Very simple. And what is standard deviation? Just positive square root of variance.